This how-to video will demonstrate the features and functions of the latest version of the Inundated Flood Visualization app. This web tool allows users to quickly view the extent and depth of a hypothetical flood in an area of interest to them, and to get some localized context about flood depth, likelihood of occurrence, and potential damage. Background data processing is done using a big data, discrete global grid systems architecture. This means that the flood information presented in this app is represented a little bit differently than regular spatial data, which actually allows the app to load and present said data faster. Having said that, no specific knowledge of spatial data is required by the user in order to use Inundated. As it currently stands, Inundated is a pre-alpha version. This means that testing, verification, and development are all ongoing, including edits to the methods, the addition of data, and refinements to the user interface. All future changes to this app will be made live and will be accompanied by an updated how-to video like this one. Especially since this is a pre-alpha version, the information contained in this app should not replace any other legal requirement or best practice for decision making. Once again, this is a pre-alpha version. Let's get started by taking a look at Inundated's user interface. There are three main sections. The first is the gray section along the left-hand side of the page, which allows you to select between the offered watersheds using radio buttons. Currently, data is only available for the Grand River watershed, which, as you can see, is automatically selected. The second section is the interactive map, which will eventually visualize the generated flood. You can zoom in and out using the plus and minus buttons, or scroll using a mouse. This map restricts the zoom to the extent of the selected watershed. And you can see this because you can't zoom out any further than this on the Grand River watershed. You can also pan by clicking and dragging within the map, but just like with the zoom, the visual extent is restricted to your selected catchment. Please note that the terms watershed and catchment are used interchangeably in this video. Finally, if you scroll down, a number of interactive controls and text boxes will appear in the third section below the map as you move through the process of generating a flood. To that end, let's get started. Once a watershed has been selected, in this case the Grand River watershed, the next step is to select a subcatchment. The subcatchments are represented in the interactive map as polygons. As you move your mouse over the various subcatchments, you'll see that they will be highlighted in turn in gray. To select a subcatchment, simply click on the polygon you would like. Once you've clicked, a progress bar will indicate that the map is loading the subcatchment, and it will automatically zoom in and center itself on the selected subcatchment as it did just now. The subcatchment will be outlined in red, as you can see, and the river channel will be highlighted in blue. Also, the subcatchment will no longer be highlighted in gray when you mouse over it, although the surrounding subcatchments still will be, because you can move from subcatchment to subcatchment simply by clicking on another one. The text in the bottom left, just below the map, will change to identify the subcatchment you've selected. And the flood generation controls will appear to the right. Scroll down to see these if you need to. The app allows you to choose between two flood generation methods, a return period-based method and a discharge-based method. Based on your choice, the next widget to the left will change. If return period is selected, as it currently is, there will be a drop-down selection box. Alternatively, if you select discharge using the radio buttons, a slider will be shown with a range of discharge values specific to the subcatchment you've selected. Let's use the return period method. Click on the down arrow to view the choice of return periods and scroll down if you need to, either on the page or in the list, or both. A return period is a value in years which describes how often a flood of a given magnitude is likely to occur. As a flood's magnitude goes up, the likelihood of its occurrence decreases, and the number of years between each event of that magnitude increases. So, by selecting a low return period, let's say 2.33 years, we're asking to see a relatively low magnitude flood which would typically occur once every 2.33 years. It's important to note that these return period values are only probabilities. So it's perfectly possible, for example, for multiple events of a 2.33 year return period's magnitude to occur within 2.33 years, or maybe even not at all. The same uncertainty applies to higher magnitude floods, for example an event of return period 200, which I'll select now by using the drop-down menu and clicking on 200 in the list. Alternatively, by clicking within the box, you can use the keyboard and type in a value of interest. But I'll go back to 200 years. And then you click to select. Once a value, either discharge or return period, has been selected, then you can go ahead and click the button to the right that says click to apply settings and generate flood. Before you do that though, you might want to scroll up to the top of the page so that you can see the full extent of the map. And go ahead and click. Once clicked, that progress bar will appear, and it'll tell you that it's generating a flood and ask you to please wait. The simulated flood will eventually appear, superimposed on the map within the subcatchment of interest. A legend will also appear in the top right-hand corner, and its values are flood depths in meters. Once you've generated a flood, notice that the descriptor text down here has changed to flood generated, no point selected. Also, 3 tabs have appeared further below. They're labeled About These Tabs, Stochastic Flood Depth, and Damage Estimation. These tabs use depth values extracted from the mapped flood to provide context on flood probability and potential damage. To obtain a depth value from the map, simply click somewhere in the flood, and you can zoom in here if that helps, in order to see your area of interest. Pick a position and click. The depth value will be extracted and shown down here in the text. In this case, the depth at the selected point is 8.62 meters. By clicking on the Stochastic Flood Depth tab down here at the bottom, a graph of return period and depth will be generated, and as always, scroll down if you need to. The clicked on point is shown here by the red circle, and the orange line shows other depths possible for that specific location. Graph values can be seen by hovering the cursor over the point or over the various points on the line. The third tab, Damage Estimation, when clicked, provides 2 drop-down menus and a button. As always, scroll down if you need to in order to see this. These 2 drop-down menus offer a set of building types and descriptions which can be used in conjunction with the clicked-on depth to estimate damage via the HasUS depth damage functions. Use the first drop-down menu to select a building type. The choices in the second drop-down menu change in reaction to your first selection. Once both selections have been made to your satisfaction, click on the button labeled Click to Calculate Damage. A graph will appear below with percentage damage on the vertical axis and flood depth in meters on the horizontal axis. To be clear, these percentages are only an estimate and do not reflect the influence of water contact time, flood velocity, or other direct and/or indirect impacts associated with flooding, such as debris impacts. Note that the value from your click is once again represented as that red dot, and just like before, you can use your cursor to hover over the point or the line to see some values. Returning to the interactive map by scrolling up, when you click on a different subcatchment polygon, for example, let's move to the left here, the interface will clear and reset, ready to generate a new flood. So you can see that those tabs down there have disappeared, and the flood generation controls have reset themselves to the way they initially were. This concludes the how-to video for the most recent pre-alpha version of Inundated. Once more, please note that the app is still under development and should not replace any formal or validated best practices for decision-making and planning.